It's not that useless. Hey guys, so today we're doing question 3, and 2, 5, and 6 are similar. So it's better, let me do 6. Yes. So question 6. So it says y is equal to x over x minus 1. So in this one we're restricted to use first principle. So we're told differentiate. The question says by using first principle find the derivative in terms of x when that. So first principle says you have to know the first principle by heart. It says f of x is equal to the limit as h approaches 0 on f of x plus h plus the one that starts, then minus f of x over h. So like we said, we can't just come and replace 0 here because we don't want it to be something over 0. That's undefined. So this is a general formula. So now we start solving here. So always write this. When the first principle, write this, then so this is step 1. Then step 2, you define this. So you say where is x, you add x plus h. So you say f of x plus h is equal to, so like I said, in this function where is x, you add this whole thing in bracket. So here you say there is x on top here, so we're going to have x plus h over, then down here again there is a x, so we're going to add this in the bracket, which is x plus h, then minus 1, then this is a, then b, we're going to have this f of x, so we're going to have f of x is equal to, what is x, we plug in what's in the bracket, what is just x, so here there's x, we're going to plug in x, so we're going to have x over, what is x, we plug in x minus 1. So now you have this, you have the minus, you have this, and now we're working on moving at x. So from here we're going to say, now we go back to this, we're going to say the limit as h, so this is step 3. The limit as h approaches 0 is this is also this. So where there is this, you add this, where there is that, you add that. So we're here, so we're going to add this. So we're going to say x plus h over x plus h minus 1 minus f of x is this. So we're going to have x over x minus 1. Everything over h. Yeah. So we simplify the top part. What we want is not to have the h in the bottom. So we do everything again. So to simplify the top part, we're going to find the common denominator. So it's a limit as h approaches 0. Then we're going to draw a line, for the common denominator here. So this line is for this on top here, is for the common denominator. Remember when we're finding 2 over 4 plus 1 over 2. And we say the common denominator here is 4. So this line is this line. So common denominator, we're going to write this x plus h minus 1 times x minus 1. So we're going to have this whole thing. This whole thing times this whole thing divided by that thing. So that's how some will say it. Some will say this times this. Then some will say we leave this one out. Just write this and that. So x plus h. All those scenarios are one and the same thing. Then x minus 1 minus. See? So that's just that and that. That times that. You see? So again here, some will say this times that divided by that. So this times that is everything here with an x this side. Then when we divide by that, this will cancel with that. So you're just going to have this whole thing and the x that is this one. All, some will say this times that. All, some will say since we have this down here, so we exclude this. So just do this thing times that thing and there. So that's x open bracket x plus h minus 1 everything over h. So you see, this top part is this part. My friend, you're going, can't you tell them recording? Yep. So we're going to continue simplifying. So as you can see, this is over 1. So we do this top thing times the inverse of this below. That's how we do multiplication over dividing. So for example, we have 2 over 3 over 4 over 2. we're going to say, let me say 4 over 8. So we're going to say 2 over 3 times 8 over 4. So this is what we're going to do here. This whole thing times 1 over 8. So this whole thing times the 1 over 8. So you can write it here. So this is that. So this is how we divide here. Yeah, so like that. So you can say this times that and everything on top here. So we're going to have limit as h approaches 0, open bracket, x plus h closed, open again, x minus 1 closed, minus x close open, x plus h minus 1 closed, over. Now we have this times the h. So we're going to have x plus h minus 1, x minus 1, then h times h. Yeah. So assuming this was written down here. So we're going to continue here by simplifying this top part here. So we're going to say limit as h approaches 0. We have this times that, that's x squared. Then this times that, that's negative x. This times that, that's positive xh. This times that, that's negative h minus. Better here you open bracket so that you can first ignore this minus. So we will just be dealing with this. Just be dealing with this. So then we have this times that, that's x squared. This times that, that's plus x. Then this times that, that's minus x. You know what? Close now. So now let's distribute the negative. So x plus h minus 1, x minus 1. So let's distribute the negative now. We're going to have x squared, so limit as h approaches 0. Can you still see? Yes. So x squared minus x plus xh minus h minus x squared is minus ax xh. I'll just flip this because here it's flipped, so to avoid confusion. And this minus that, that's positive. So positive x over x plus h minus 1, x minus 1. So here people say group electing on top here. Then some, we just calculate from this is negative x, this is positive x. When you put them together, they give us a 0. So this and this will cancel. Then this is positive x squared, this is negative x squared, this and this will cancel. This is xh and this is negative xh. So this and this will give them 0. So remaining h. So we say minus h over x plus h minus 1. Okay. Or close to then open x minus 1. So you see, I wasn't stressing much with the denominator because it's not important. So you see, this is times. This whole thing is times. So you can simply cancel this h. So that has negative 1. And to get the limit as h equals 0, the limit as h equals 0. So we're going to have negative 1 over, that has been cancelled. So we're going to have x plus h minus 1. And then we're going to have x minus 1. So from here you can now plug in the limit. So we're going to have minus 1 over x plus 0 minus 1 x minus 1. So this is h, so you plug in this h, don't forget. So we're going to have minus 1 over x minus 1, this, and here we have x minus 1. So this thing is just equal to negative, plus equal to negative 1 over x minus 1. So that's your answer. So you discovered when you differentiate this using quotient or product rule. If I say product rule, you do x, then this can go on top, which is x minus 1 to the power negative 1. Then now you use product rule here. So you can use product rule. You'll find that you arrive to the answer that we found. So yeah, if you use quotient rule here, you find that you arrive to the answer that we found. So let's move on here. We're going to do the 3 of 3. So question 3 says Find by using the first principle, find the derivative in terms of x. So we are simply differentiating with respect to x. So it says use the first principle. We're limited to using the first principle. So question 3 of 3 says f of x. Oosh, the light. If you can see, it says f of x is equal to cos 3x. Yeah. So using the first principle, like I said, you start with the formula. So stage 1, write the formula down. F prime of x is equal to the limit as h approaches 0 on f of x plus h plus minus f of x over h. So we define this. So step 2, f open brackets f of x minus h plus h is equal to, in the function here where is x you put h plus h. So you say cos 3x plus h. And then this can also be written as cos 3x plus 3h. Yeah, I don't use black, so hope you see it. Then f this one, f of x is equal to cos 3. Where is x? You add an x. Okay. Then from here you have this and this, you have this and this. You also have the h, which is 0. So you replace x with 0 because we don't want to have a 0 in the denominator. So we have the limit as h approaches 0 on this is also this. So we're going to use this. So we're going to say cos open bracket 3x plus 3h closed minus f of x. So we're going to have cos 3x over everything h. So this whole thing is an identity, and this identity says, so you can write, but we know that cos A minus cos B is equal to negative 2 sin A plus B over 2 sin A minus B over 2. So here it's always plus minus. Then we want to x. So that leaves us with the limit as h approaches 0. So this thing is this whole thing. Cos A is this one, cos A. So this is our A. Then minus cos B is this one, cos B. So this whole thing is our B. So meaning we're going to replace this whole thing, which is this whole thing, by this whole thing. This whole thing. Things mathematics are so sensitive. You say by the same times. You say with, just like that. So replacing this whole thing by that, we'll have negative 2 sin A, we say this is, which is 3x plus 3h, which is this 3x plus 3h. Then have a plus here, which is plus B is this one, 3x over 2. Then sin, we have our A, which is this, we're going to say 3x plus 3h minus B, which is 3x over 2. Then this whole thing is just this whole thing, meaning we have an over h here, so we're going to have anything over h. So we continue with limit as h approaches 0. I'm going to have look, now we're going to put the like things. So we have negative 2 sin 3x and 3x are like them, so we can add this. So this is it, 6x plus 3h over 2 sin this. So here we have 3x and that minus 3x. So that gives us a 0. So that's 0. Into this and this gives us a 0. So we're going to have 3h over 2. Everything over h. So we're going to say limit as h approaches 0, negative 2 sin 6x plus 3h over 2. So here, sin 3h over everything over h. Okay, so I've just rewritten everything. Wow. So let's continue. And here we're going to, you can simply separate this, so we can have limit as h approaches 0 minus 2 sine. Can we see a bit? Yeah, perfect. So we have 2 sine 6x over 2 plus 3h over 2. We can write it like that. It's okay, since the common denominator just cannot be 2. And then do the power of 13, I'm going to go back to that. So we're going to have sine 3h over 2 everything over h. So we're going to have limit as h approaches 0, we'll have negative 2 sine. This is 1 and this 3. So we're going to have 3. We're going to have 3x plus 3h over 2 sine 3h over 2 over h. So from here we know that sine x over x is equals to 1. This is an identity, meaning also sine, we also know that sine, whatever number we're going to put here, x over this same number that is here, then there is 1. So we're going to force this one on top here to be, especially this part, to be written like this. You see? So we're going to do that. To achieve this, we're going to multiply both the numerator and the denominator by 3 over 2. This 3 over 2, we're going to multiply it. We're going to multiply the numerator by this 3 over 2. Then if we leave it like that, it means we've changed the thing. So we're going to do again over 3 over 2, so that this can be 1. Meaning we're going to change the thing. Then here, I haven't been writing this properly. So this is supposed to be in the brackets. I believe there's no doubt about that. This is supposed to be in the brackets everywhere. Just starting from the beginning. Even this is supposed to be in brackets if you want. Brackets. Yes. So we're going to distribute these times. We're going to have limit as h approaches 0. We're going to have this whole thing is one thing because it's times. If there was a plus here, this would have been critical. But since it's times, I hope you understand. Meaning, what I'm trying to put up is that when I say 3 plus 2 x, this x will have to, it can be here or it can be this side in front. It's okay, it can also be written as you see. So this is what I'm trying to do here. So this whole thing times this whole thing, we're going to have 3 over 2 minus this minus 3 over 2, this 3 over 2, then this 2, then the sign, in bracket 3x plus 3h over 2 sine 3h over 2. Then again here we can have 2 times 4. We can write this to this side or you can write it this side. Then if let's say it had over a number, maybe 2, I can also write this as 2 4 over 2. There's no difference here. Then if I cancel this, it's not something that you can be surprised you're going to be 2 times 2. You see? So just because I'm putting the over this side and leaving it this side doesn't mean I've changed anything. So for me to make my mathematics look beautiful, this h is like this 2 here. So I will not write it in between or this side, I'll write it at the far end here. So I'll just write it at the far end here. So I'm going to do h times this whole thing. So this is going to be 3h over 2. So if you see, if you're sharp and you know what you're doing, you can write over there and whatever. I don't think it's about sharpness, it's just about seeing. So if you can see, you can see. If you can't, it's better to write it like that when we reach this stage. So if you can see here, we have the sine, then we have our n, which is 3 over 2, then we have our h, which is just the x. So the n is 2 over yes. So we have our nx and we have our nx. So this is our n, this is our x. So in short, this whole thing, this thing is equal to 1. This thing is equal to 1. So you don't have to write that, you just have to know that now this thing is 1. Or you can write it here, sine 3h over 2 over 3h over 2 is equals to 1. So you see limit as h approaches 0 minus on negative. This is 2, this is 2, so this will cancel. So we're remaining with 3 sine 3x plus 3h over 2 times 1. So if we forget to do 1 second, you see how it reduced. That. Yeah, then from here now you can replace the 0. So then you have negative 3 sine 3x plus 3 times 0 is just 0. And this is equal to negative 3 sine. Remove the 0 here, then you have 3. And now, this is our answer. So yeah, it has taken long because of the explanation and everything. So if you go through it 1, you go through it 2, you go through it 3, then you're good to go. Myself, this is the 7th time going through, and I'm still managing to make mistakes. Yes, so I made a mistake here. I didn't write the x down. I also made a mistake here. I repeated. I just repeated the whole thing because I didn't know what to do next. I was supposed to speak again, so that's how I ended up writing this whole thing. Where else did I make a mistake? Yeah, I also made a mistake here. Yes, I forgot to say follow x-1 on YouTube and on Facebook. I'll be trying to post whatever I find in the tutorial I post. So yeah, just go through more than once and you'll be okay.